Hi everyone, today we're going to study non-right triangles, then later on we will discuss law of sines. First, let us define a triangle. A triangle is a polygon having 3 sides and 3 angles. Let us label a triangle. Here's a triangle. We're going to use capital letters or Greek letters to denote an angle. We have capital A, capital B, capital C, and other letters of the alphabet to denote an angle. Also, I have 4 commonly used Greek letters for an angle. The first is theta. This symbol is phi. The next is the alpha, and the symbol is for beta. For our discussion, we will use capital letters. We have here a triangle with angle A is here, angle B, and angle C. Now let us label the sides. We're going to use small letters to denote sides. Small a, small b, small c, so on and so forth. Let us label the sides. Let's begin with small a. We will make sure that the small a should come here because this is the opposite side of angle A. For small b, which is the side, we should put it here because this is the side opposite angle B. And for side C, this is the side which is the opposite of the angle C. Let's go now to oblique triangle. As per definition, any triangle that is not a right triangle is an oblique triangle. Solving an oblique triangle means finding the measurements of all 3 angles and all 3 sides. To do so, we need to start with at least 3 of these values, including at least 1 of the sides. Let us discuss the 5 oblique triangle cases. Case 1 is ASA, which means angle, side, angle. In this case, measurements of 2 angles and the included side are given. Example is this triangle. There are 2 angles. One is 50 degrees. The other is 30 degrees, and this is the included side with length 10 centimeter. Case 2 is AAS, which means angle, angle, side. In this case, measurements of 2 angles and a side that is not between the known angles are given. Here is an example of a triangle with 2 angles, namely 30 degrees and 50 degrees respectively. And there is one side, and this is 7 centimeter. We can see here that this 7 centimeter side is opposite the 50 degree angle. Case 3 is SSA, which means side, side, angle. In this case, measurements of 2 sides and an angle that is not between the known sides are given. Here is an example. A triangle with 2 sides, namely 10 centimeter on this side and 7 centimeter on this side. And one angle of 50 degrees is given in this corner. Case 4 is SAS, which means side, angle, side. In this case, measurements of two sides and an included angle are given. Here is an example. There are two sides. Here is 10 inches. The other side in here is 15 inches. And the included angle is 62 degrees. Case 5 is SSS, which means side, side, side. In this case, measurements of three sides are given. Here is a triangle whose sides are 10 cm, 7 cm, and 5 cm respectively. Here is the summary of the 5 oblique triangle cases. The case 1 is ASA, where two angles and the included side are given. Case 2 is AAS, where two angles and a side that is not between the known angles are given. Case 3 is SSA, where two sides and an angle that is not between the known sides are given. While case 4 is SAS, where two sides and an included angle are given. The case 5 is SSS, where three sides are given. For the solution, the first three cases can be solved by the law of sines, while cases 4 and 5 can be solved by law of cosines. Hi everyone. Today we're going to study law of sines. The law of sines states that the ratio of the sine of one angle of a triangle to the length of its opposite side is equal to the remaining two ratios of angle sine to its corresponding opposite side. We have a triangle here, ABC, and the sides are labeled accordingly to its opposite angle. As you see, angle A is here with side A, angle B is here with side B here, and angle C here with side C in here. In symbol, we can write the law of sines as sine of angle A over side A is equal to sine of angle B over side B equals sine of angle C over side C. Any pair of proportions may be used to solve for a missing angle or side. The law of sines can be written also as this is the side A over the sine of angle A is equal to side B over sine of angle B equals side C over the sine of angle C. The law of sines is used to solve oblique triangles of cases such as these three cases. The case 1 is ASA, this is angle, side, angle, where two angles and the included side are given. Case 2 is AAS, angle, angle, side, and two angles and a side that is not between the known angles are given. And the case 3, SSA, side, side, angle, where two sides and an angle that is not between the known sides are given. For the case 3, there are three possibilities. The first possibility is there is no solution if the absolute value of sin x is greater than 1. In this case, no such triangle exists. The second possibility, there will be two solutions if the absolute value of sin x is less than 1 and obtuse angle exists. Two different triangles exist where we can have sin x and sine of the angle 180 degrees minus x. Both exist. The third possibility is there is one solution if the absolute value of sin x is less than 1 and obtuse angle does not exist. So in here, exactly one triangle exists. There are points to remember. The first one is sum of the angles in a triangle is 180 degrees. Second, the range of sine is the closed interval from -1 to +1. And the third is sin x is equal to sine of the angle 180 degrees minus x. Let us have example 1. In a triangle, given the angle A equals 56 degrees, angle C equals 20 degrees, and side C equals 1.7 meters. Find side A. Let us draw the triangle and label them properly. So here is the angle A, which is 56. Here it is angle C with 20 degrees. And C, which is 1.7 meters, is opposite angle C. Side A here is opposite the angle A, which is 56 degrees. So let us use the sine law, and this is A over sine of angle A equals side C over sine of angle C. Let us substitute the values. So A we copy here over the sine. A becomes sine 56 degrees equals the C is now substituted by 1.7 and sine C is now sine 20 degrees. Let us simplify further. Let us cross multiply the sine 56 degrees on the right side to the numerator. So we have A equals this 1.7 times the sine of 56 degrees all over sine 20 degrees. Let us use our calculator in degree mode. So you multiply this 1.7 by sine 56 degrees, then divide by the sine 20 degrees. You will get the value of A equals 4.1, and this is in meters. So this is the value of A, our final answer. Let's have example 2. Solve the triangle given angle A equals 98 degrees, angle C equals 43 degrees, and B equals 22 centimeters. When we say solve the triangle, it means we need to find the three missing parts of the triangle. First, let us write the given and the required values. Angle A is 98 degrees. Angle C is 43 degrees. Angle B is unknown. Side A is unknown. Side C is unknown. Side B equals 22 centimeters. Let us draw the triangle. So this angle A, being an obtuse angle, I place it here. And the angle here, I put it as angle C, the 43 degrees. And this B is the included side, and it is written as the base. So the missing parts are the angle B, the side A, and the side C. Let us begin by solving the angle B. We know that the sum of the angles of the triangle is 180 degrees. And in symbol we can write A plus B plus C equals 180 degrees. Let us substitute the values. A is now 98 degrees and the C is 43 degrees. Let us add the 98 and 43. It becomes 141. The angle B is copied, is equal to the right hand side is the 180 degrees. Let us isolate B. So let us transpose the 141 degrees to the right. So the positive becomes negative 141 degrees. Getting the difference, we have now B equals 39 degrees. So let us copy this answer opposite the angle B on this side. Let us solve now for side A. Solving for A, we have A over sine A equals B over sine B. Please notice that we are using the side B and the angle B here because we cannot use the C over the sine C because C here is also unknown. Substituting the values now, we have A over the sine A becomes sine of 98 degrees is equal to the side B is 22 centimeters and the sine of B is 39 degrees. Simplifying further, let us cross multiply this sine 98 degrees to the right side to the numerator. So we have now A equals 22 times the sine 98 degrees all over the sine 39 degrees. Always use calculator in degree mode. So the value of A is equal to 34.6. And the unit of measurement, we will copy the same with side B, which is centimeter. We will copy this answer opposite the side A on this part. Then let us clear the board and continue finding for side C. Solving for C, again we will use the sine law. So this is C over sine of angle C equals side B over the sine of angle B. Substituting the values, C over sine of angle C becomes 43 degrees is equal to the B or side B is 22 and the sine of angle B is now sine of 39 degrees. Let us simplify further. The sine 43 degrees is now cross multiplied to the numerator 22. So we have now C equals 22 times sine 43 degrees all over sine 39 degrees. So let us use our calculator in degree mode. The value of C is 23.8. Again, this is in centimeter. So we are to write this now, opposite side C. So we are now complete with the missing values in example 2. Just a quick check if our answers are correct. There is a proportion that we may follow. It says here, the biggest angle is opposite the longest side. The biggest angle here is 98, and we can see here that the longest side is also the side A. Another one is the smallest angle is opposite the shortest side. The smallest angle here is 39 degrees, and the shortest side is the side B, which is 22 centimeter. So now we are done with our solution for example 2. Let us have example 3. Solve the triangle. Given angle A equals 80 degrees, side A equals 120 centimeters, and side B equals 121 centimeters. If there is more than one possible solution, show both. Let us first write the given and the required values. Angle A is 80 degrees. Angle B is unknown. It is blank. Angle C is also blank. Side A equals 120 centimeters. Side B equals 121 centimeters. Side C equals unknown. Let us draw the triangle ABC. From the given, angle A is here, which is 80 degrees. The opposite side, small a, is 120 centimeters. And angle B is here, which is unknown. The opposite side is 121 centimeters. First, let us solve for angle B. Using sine law, it says sine of angle B over side B equals the sine of angle A over side A. Let us substitute the values. Sine B over side B is 121 equals the sine A becomes sine 80 degrees all over the side A is 120 centimeters. Let us simplify further. This 121 will be cross multiplied on the right side with the numerator. So we have sine B equals 121 times sine of 80 degrees all over 120. We will use the calculator in degree mode. So the sine B is equal to 0.99301. To get the value of angle B, we will use the inverse sine. So use again your calculator. B equals inverse sine of this value. The angle B is 83.22 degrees. let us write this value opposite angle B in here. Let us now check for obtuse angle possibility for this angle B. We know that we have an equation which says sine of angle B is equal to the sine of the 180 degrees minus this B. So if we're going to substitute the values, we will have the sine of 83.22 degrees is equal to the sine of 180 degrees minus 83.22 degrees. Getting the difference, we will get this 96.78. So this 96.78 is an obtuse angle. And we know that the sum of all angles in a triangle is equal to 180 degrees. It means to say, if I'm going to add this 96.78 with angle A, the sum will be subtracted to 180 degrees. Still, there is a value that we can get for another angle C. It means the obtuse angle is possible for this problem. So we have another value for angle B, which is this 96.78 degrees. Now, let us compute for angle C with respect to the value of angle B, that is 83.22 degrees. From the relation of the angles, which is the sum of A plus B plus C equals 180 degrees, we can substitute the values that A is 80 and the B is 83.22. We will now get the angle C. Let us add these two values. We will get 163.22 degrees plus C equals 180 degrees. Let us isolate the angle C. We will transpose the 163.22 on the other side. Of course, the sign must be changed. So we have 180 degrees minus 163.22. The difference is 16.78 degrees. So this is the angle C, given that angle B is 83.22 degrees. So let us write this opposite this angle C. Now, let us solve for another angle C for the second triangle, given now that this angle B equals 96.78 degrees. Here again is the relationship of the angles A plus B plus C equals 180 degrees. Let us substitute. The angles A becomes 80 degrees and the B, we will use the second value 96.78 plus C equals 180 degrees. Let us add these two values. So we have 176.78 degrees plus C equals 180 degrees. Now, to get the value of C, we will transpose this 176.78 to the right. So we have now 180 degrees minus 176.78 degrees. So the difference is 3.22 degrees. So we have the second value of angle C, which is 3.22 degrees, and it is written now opposite the angle C. Now let us go to solve for side C when your angle C is 16.78 degrees. Using the sine law, we have C over the sine of angle C equals side A over the sine of angle A. We will substitute the values. We have C over the sine of C is now the 16.78 degrees equals the side A is 120 and the sine of angle A is now sine 80 degrees. Let us simplify further. This sine 16.78 degrees we will cross multiply to the right in the numerator. So we have the value of C equals 120 times the sine 16.78 degrees all over the sine 80 degrees. So we use our calculator. In degree mode, the value of C equals 35.2. The unit of measurement is the same with sides A and B, which is centimeter. And we have the value of side C, that is 35.2 centimeter, given that the angle C is 16.78 degrees. Now let us solve for C, or side C, when your angle C equals 3.22 degrees. Sine law is here. C over sine of capital C equals side A over the sine of angle A. Substituting the values, C over sine 3.22 degrees equals 120 over the sine of 80 degrees. Let us simplify further. We will cross multiply the sine 3.22 degrees to the right to the numerator. So we have now C equals 120 times the sine 3.22 degrees all over sine 80 degrees. So using the calculator in degree mode, we will get the value of C, which is 6.8. Of course, this is in centimeter. So another value of side C when the angle C is 3.22 degrees. So we will write it over here. To summarize, we have two triangles. The triangle 1 has 3 angles and 3 sides written like this. And the triangle 2 has angles and sides written like this. This is our final answer. I hope you learned something from this video. See you again next time.